Can you believe it? While navies worldwide are still competing over whose missiles are more advanced and expensive, the Chinese Navy has quietly overturned the table, rewriting the rulebook of modern naval warfare through a near brute force approach. Recently, as footage from live fire tests ignited global military headlines, the news that the Type 055B destroyer Lhasa had become the world's first warship to deploy a combat-ready electromagnetic railgun has evolved from rumor to an undeniable reality. This is not merely the deployment of a new weapon. It is more like a blade slicing through an era. Behind it lies a revolution led by China, transforming everything from energy forms to combat concepts. Let us look beyond the jaw-dropping technical specifications and delve into what this deployment truly signifies. At its core lies a silent yet monumental power revolution. Traditional naval guns rely on chemical energy, inherently limited in destructive potential. While the dream of electromagnetic cannons is compelling, it has long been haunted by two nightmares: how to unleash the primal force needed to accelerate projectiles to multiples of the speed of sound within a warship's confined space and limited energy reserves, and how to make the barrel withstand the extreme heat generated by such high-speed friction, heat intense enough to melt metal. These two world-class challenges have caused electromagnetic cannon projects in multiple technologically advanced nations to fail, leaving them stuck in the land-based testing phase for years. China's breakthrough, however, first came from academician Ma Weiming, hailed as the father of China's electromagnetic catapult technology, and his team. The medium-voltage direct current integrated power system they developed for the Type 055B destroyer and China's entire new generation of warships serves as the energy heart unlocking these capabilities. This system functions like a master martial artist with profound inner strength, seamlessly integrating and coordinating the ship's entire power supply, whether the surging horsepower propelling this 10,000-ton behemoth through waves or the precise currents powering phased array radars and electronic warfare systems. Upon receiving a firing command, it can instantly dispatch over 100 megawatts of peak power within 2 seconds, equivalent to the total electricity consumption of a medium-sized city at that instant, delivering it precisely and without loss to the intricate array of electromagnetic acceleration coils. Compared to the medium-voltage AC systems used on U.S. Ford-class carriers, our medium-voltage DC architecture achieves generational superiority in efficiency, stability, and transient response. With 90% energy conversion efficiency and zero incidents across thousands of firings, it delivers not only greater explosive power but also unmatched reliability and maintainability during prolonged operations at sea. With this immense yet tamed energy harnessed, the next challenge was to subdue the all-consuming flames. When an 8-kilogram specialized tungsten alloy projectile accelerates to 7 times the speed of sound, within a several-meter-long rail, the friction between it and the rail material rivals that of a meteorite entering the atmosphere. The solution devised by Chinese engineers represents the pinnacle of materials science and engineering ingenuity: a barrel constructed from high-performance titanium alloy, coated with a specialized ablation-resistant layer, and supported by a precision liquid cooling system that circulates internally to dissipate heat. This comprehensive approach successfully extends the barrel's service life to over 500 rounds, the operational requirement for combat, enabling sustained, high-intensity salvos rather than cautious, single-use lab demonstrations. The projectile itself, endowed with astonishing kinetic energy, is a high-tech masterpiece. Integrated within it are a miniaturized Beidou 3 navigation module, a millimeter-wave radar seeker, and an infrared imaging system. After launching along a high apex trajectory through the thin atmosphere, it autonomously seeks and identifies critical targets like a sharp-eyed falcon. Even amidst complex sea backgrounds and electronic jamming, it maintains astonishing sub-meter accuracy. This means it can selectively penetrate enemy ship bridge structures, vertical launch system covers, or propulsion compartments, delivering surgical precision strikes to paralyze enemy combat capabilities with minimal collateral damage. It is precisely these clustered breakthroughs in foundational technologies that have endowed the electromagnetic railgun aboard the Type 055B destroyer with 3 disruptive combat advantages, transforming it from a sci-fi concept into a true game-changer on the naval battlefield. Foremost among these is its impact on traditional anti-ship warfare paradigms. While mainstream supersonic anti-ship missiles boast ranges of hundreds or even thousands of kilometers, each missile costs millions or tens of millions of dollars and remains vulnerable to interception by multi-layered air defense systems during flight. In contrast, the kinetic projectile fired by an electromagnetic railgun is estimated to cost only 1/20th of a high-end anti-ship missile, yet it can traverse 300 kilometers in just 138 seconds, plunging downward at a staggering speed of Mach 7. The immense kinetic energy generated by its terminal velocity is sufficient to penetrate 12 layers of reinforced steel plate consecutively, rendering the main armor belts of any active-duty warship virtually useless. More critically, its near-vertical attack trajectory and extreme velocity leave existing shipborne air defense systems with virtually no effective intercept window. You cannot counter a super penetrator traveling several times the speed of sound using methods designed for subsonic cruise missiles or even ballistic missiles. This creates a terrifying imbalance in naval warfare. One side can deliver unstoppable destructive energy at near zero cost and extremely high rates of fire, while the other may struggle to defend even with its entire stockpile of expensive anti-aircraft missiles. Second, its operational flexibility far exceeds a single anti-ship function. By swapping out different warhead modules, this electromagnetic cannon instantly transforms into the fleet's outermost, robust shield. Against the growing threats of hypersonic anti-ship missiles and drone swarms, it can launch specialized programmable fragmentation rounds or kinetic interceptors. Leveraging its extraordinary firing rate and projectile velocity, it can generate a dense metal storm at long range, effectively intercepting, or even destroying high-speed, highly maneuverable targets. Seamlessly integrated with the ship's HQ series long-range air defense missiles and laser close-in weapons systems, it constructs an impenetrable electromagnetic dome, a comprehensive air defense and missile defense system spanning from 300 kilometers out to within a few kilometers. This seamless transition from the sharpest spear to the strongest shield, achieved within a single reload cycle, significantly expands the captain's tactical options, elevating the Type 055B's individual combat capability to unprecedented heights. Shifting our focus beyond this single gun and vessel reveals a grander panorama. The commissioning of the 055B Lhasa marks not an isolated event, but an inevitable outcome and resounding declaration of China's accumulated prowess and comprehensive breakthroughs in cutting-edge electromagnetic application technologies. From the world's first operational shipborne electromagnetic catapult system on the Fujian aircraft carrier to the combat-ready electromagnetic railgun now deployed on this 10,000-ton destroyer, their technological core, medium-voltage direct current integrated power management, and precise electromagnetic energy release control, shares a common origin and underlying principles. Thus, the formal commissioning of the Lhasa's electromagnetic railgun carries symbolic significance equal to its operational impact. It formally signals that the backbone of naval firepower is partially shifting back from missile systems focused on intelligence and penetration capabilities toward a new era of physics, pursuing extreme velocity and absolute kinetic energy. As the world's first integrated combat platform featuring a large-caliber electromagnetic railgun, high-power laser defense systems, and an ultra-large universal vertical launch system, the Type 055B destroyer has already outlined the clear contours of next-generation flagship warships. Highly efficient, versatile, sustainable, and exceptionally cost-effective. It is foreseeable that as this technology matures and becomes more compact, it will not only equip additional Type 055B destroyers but may also appear on Type 076 amphibious assault ships and a broader range of naval platforms in the future, forming an omnipresent electromagnetic fire network within China's blue water naval formations. This signifies that in the silent race for future maritime supremacy, China has firmly secured a leading position through solid technological innovation and engineering practice. The profound impact of this advancement will undoubtedly continue to ripple outward across the oceans, resonating into the distant future.